When replacing a service and fuse panel with a load center and installing a disconnecting means outside next to the meter base, the load center effectively becomes a subpanel. This is an important distinction because it dictates specific wiring and grounding requirements according to electrical codes. The key is understanding how to properly run service entrance and grounded, or SEU, cable to the new load center from the disconnect while maintaining a safe and code-compliant electrical system. The crucial element is to avoid bonding the neutral conductor at the disconnect. Bonding the neutral at the disconnect would create parallel neutral paths, which is a violation of electrical codes and can lead to dangerous circulating currents. Here's a detailed explanation of the process. Firstly, establish the service disconnect. The service disconnect serves as the main point of isolation for the entire electrical system. It should be located outside, adjacent to the meter base for easy access by utility workers and emergency personnel. The disconnect must be properly sized to handle the anticipated load of the dwelling. Secondly, run the SEU cable from the service disconnect to the load center. SEU cable typically consists of two insulated phase conductors and a bare neutral conductor wrapped helically around the insulated conductors. Ensure the SEU cable is appropriately sized for the service amperage rating, consulting applicable NEC tables for proper ampacity based on conductor size and insulation type. Thirdly, at the service disconnect, connect the two phase conductors of the SEU cable to the terminals of the disconnect switch or breaker. The bare neutral conductor of the SEU cable is connected to the neutral terminal or busbar within the disconnect enclosure. Important, do not bond the neutral busbar to the enclosure at the disconnect. The neutral must remain isolated at this point. Fourthly, at the load center, connect the two-phase conductors of the SEU cable to the main breaker terminals. The bare neutral conductor of the SEU cable is connected to the neutral busbar in the load center. Fifthly, the neutral busbar in the load center must be isolated from the enclosure. This is a critical step because the load center is now acting as a subpanel. The neutral busbar should be clearly marked as the neutral and kept separate from the ground busbar. Sixthly, connect the ground busbar in the load center to the metal enclosure of the load center. The ground busbar should be connected to a grounding electrode system typically consisting of ground rods, a metal water pipe, or a concrete encased electrode, in accordance with NEC requirements. This grounding system provides a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices such as circuit breakers. Seventhly, install a separate equipment grounding conductor from the ground busbar in the load center back to the service disconnect. This equipment grounding conductor provides a dedicated grounding path for any metallic enclosures, appliances, or equipment connected to circuits originating from the load center. The equipment grounding conductor must be sized according to NEC table 250.122, based on the rating of the overcurrent protection device protecting the circuit. Eighthly, ensure all branch circuits originating from the load center have a dedicated equipment grounding conductor that is connected to the ground busbar in the load center and extends to the grounding terminals of all outlets and equipment served by the circuit. This ensures that any fault currents will safely return to the source, tripping the circuit breaker and preventing electrical shock hazards. Ninthly, label the load center as a subpanel. This labeling is important for future reference and helps prevent confusion during maintenance or modifications to the electrical system. It also serves as a reminder that the neutral is not bonded at the load center. Tenthly, verify all connections are tight and secure. Loose connections can cause overheating, arcing, and potential fire hazards. Use a torque wrench to tighten connections to the manufacturer's specified torque values. Also visually inspect all wiring for proper insulation and secure connections. Remember that the National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. It is essential to consult the latest edition of the NEC and follow all applicable codes and standards to ensure a safe and code-compliant installation. Understanding the difference between a service panel and a subpanel is crucial. A service panel is the main panel where the electrical service enters the building, and it is where the neutral and ground are bonded together. A subpanel, on the other hand, is a panel fed from the service panel, and the neutral and ground must be kept separate. The reason for keeping the neutral and ground separate in a subpanel is to prevent circulating currents on the grounding system. When the neutral and ground are bonded together at multiple locations, it creates parallel paths for neutral current to flow. This can cause the grounding system to become energized, which can be a shock hazard. By keeping the neutral and ground separate in a subpanel, you ensure that all neutral current flows back to the service panel and the neutral conductor, and the grounding system only carries fault current. The equipment grounding conductor provides a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices such as circuit breakers. This helps to quickly clear faults and minimize the risk of electrical shock or fire. When working with electrical systems, always follow safe work practices. To energize circuits before working on them, wear appropriate personal protective equipment such as safety glasses and gloves, and use insulated tools. If you are not comfortable working with electricity, consult a qualified electrician. In summary, when installing a load center as a subpanel with SEU cable, remember these key points. Firstly, do not bond the neutral at the disconnect. Secondly, isolate the neutral busbar from the enclosure in the load center. Thirdly, connect the ground busbar to the enclosure and the grounding electrode system. Fourthly, run a separate equipment grounding conductor from the ground busbar in the load center back to the service disconnect. Fifthly, ensure all branch circuits have a dedicated equipment grounding conductor. And finally, label the load center as a subpanel. By following these steps, you can ensure a safe and code-compliant electrical installation. Understanding the code requirements is important for safely installing a subpanel. Always consult the latest edition of the NEC for specific requirements in your area.